Why is that important? You mentioned yesterday how many times the door is opened in a surgery room throughout an operation?
CDC basically says that on average, operating doors open 6 times every 10 minutes. That's a lot.
What?
Yeah, that's crazy, right?
Wow.
So again, I think a lot of that has to do with education, right? Really trying to understand how does pressurization really help me from a sterility standpoint in this space. But that also helps the hospital. If they see that visually, how many times that door is opening, they can kind of say, okay, do I have a workflow issue? Do I have is my anesthesia, nurse going from this operating room to that operating room too much? My booking. That's the kind of stuff that gives them the power, right, to try to manage that infection risk better.
So now we're going to walk into the healthcare suite and get a tour of this area. So let's see what we got here.
All right. So what we got here is our healthcare demo suite. And what it does is like Jim had kind of indicated earlier, it demonstrates the 4 different pressure zones, right, that are all within one zone of a healthcare, facility. So we have a patient room, which is its own neutral pressure zone. We have an isolation room, which has an anteroom. So there's 2 pressure zones going on there. And then we have an OR suite, which is at a positive pressure. And then we have this clean corridor, right, which provides and feeds these rooms if they change any kind of pressure.
So it's for me, and I'm not familiar with hospital layout that well, is this typical of what you would see, like an OR room and
kind of? I mean, you'll have different. Every hospital zone is kind of different. Right? Okay. So you may have a certain percentage of isolation rooms, but are they on the same floor? No. Right. They're intermixed, and sometimes they can be. But even with COVID, patient rooms were also turned into isolation rooms, right, during pandemic.
Got it.
So things like that. So yeah, you can see all kinds of demand.
Well, let's walk into the OR. That's the coolest looking room. And then I've got some video of those that we can show in a little bit. So this is representative of like a legit, like what you would really see.
Yeah, this OR suite that we built, we put a lot of investment into these demo suites. And this is a FGI code OR suite.
Okay,
right?
Built per that code.
Correct.
Gotcha.
Correct. And
wow,
so
that's impressive.
Yeah, you can see that we have a number of different things going on in this room, and it's all about infectious management and maintaining a sustainable type of an approach, right?
Right.
So that's one of the big challenges I think a lot of hospitals have is that they're trying to manage their operating costs, right, while still trying to maintain a high level of technology, a high level, of surgery capabilities.
Right.
And that's really hard to do when you're dealing with, some 60-year-old buildings.
Right.
So.
Oh, I bet.
So that's what we did. So we put a lot of technology in here. But this, when I say FGI code and also ASHRAE 170 code, you're seeing that we have, low air exhausts. We have 3 of them in the room. The door counts as 1. So we've actually got 4, which is a recommendation from your VA medical type groups. But code for right now is between 2 and 3, right, is the recommendation. But we get a lot better performance with the additional low air return.
So let's walk around the room. Why don't you follow us, Jim, and Dave, you could tell us kind of what's going on here, and we'll just walk around and you show us the components.
Sure. So within this room, we're showing what we call the Smart Suite system.
Okay.
And it's made up of 3 different types of technologies, right? It's made up of the SLD, which is your single large diffuser, right? Which comes down over the patient. That creates a sterile field. It's HEPA-filtered. And then as that curtain comes down, it goes down to the low end returns and then obviously evacuates from the space.
Okay, so for those who don't know, what we're looking at here is a grid supplier diffuser, but it's got a HEPA filter in there.
Correct.
Supplying the air to the space.
Right down over the surgical space.
Right down over the and this is where the return happens.
Right. Because you want those low air returns because you don't want that dirty air, right? As it comes over the patient, sweeps down along the floor, you don't want that coming back into the surgical site. Right?
Got it.
So you want that going into the low air return.
One pass.
Coming
in, going out. Gotcha. So it's picking up anything we don't want in here.
Right.
Got
it. And that is one of the main factors for reducing your infectious risk is removing as much particulate, CFUs, right? Particulate means CFUs, so colony forming units. You want to get those out of the space because the more CFUs you have in the space, the more risk you're going to have of infection.
Gotcha. So there's a low air return here.
Yep.
There's one over here.
Right.
And I see there's some sensors in there, which we could talk about. And then there's one on this side of the building as well.
Exactly.
Jim, you're doing amazing with that camera. Jim is our cameraman, by the way.
Better than I did.
So,
but yeah, so it's made up of, so it's made up of this diffuser, but it has to work in concert, right? If you have just supply coming in, it's got to work in concert with the exhaust, right? If you have, just like we talked about on the research side, if you don't have supply working with exhaust, you're going to get fluctuations and unstable airflow. Right. And
it's got to all be linked together.
It's got to be linked together, right?
Got it.
And so, again, SLD, single large diffuser, and then you got the Phoenix Controls Venturi valves on supply and exhaust, supply coming through that diffuser. And then you have what we call the beacon software, right? Okay. So we got all these sensors in this room, all non-invasive, like you saw there in the low air returns. We've got particulate monitoring. We're monitoring TVOC. We're monitoring occupancy. We're monitoring diffuser velocity, right? On both the exhaust and the supply.
Lots of data.
Lots of data, right? And so that data feeds through that beacon software and then gives us a risk map, right? And that risk map allows us to inform the hospital and let them know what areas or what the risk is of this space with respect
based on the data you're collecting.
Based on the data we're collecting.
Gotcha.
So Onsite LLC, they're the infection control consultants that we've been partnering with, and they have developed a medical algorithm, right, that lays on our hardware, software, and then to interpret that data.
Got it.
Right? And so that helps the hospital not only understand what their infectious risk is, but it also helps the hospital find a root cause. Like, what is it that's contributing to it, right? And so that's where this dashboard, for the hospital. And again, this isn't something you would necessarily see in an OR. You would, this would be like for an OR manager or an IP director, infection prevention director, just to kind of calculate, to kind of visually see what they're.
Because the surgeon's got enough going on. He's not going to be looking.
Really does.
Yeah.
Yeah. And speaking of surgeons, that's one of the nice things about this. All this state that we have in here as an environment, we can configure it to match the doctor, what they want. We can set up the parameters so that it's, friendly for craniotomies or hip surgery, whatever you want. If these parameters like temperature and humidity, all those things, if they want those changed per procedure, we can do that too.
And per doctor.
Per doctor.
Could you show that? You were showing that yesterday.
Yeah. So this would be for right now. We have it set up for Dr. Watson. Dr. Watson likes it at 20 air changes per hour. He wants his particulate count cut at an ISO class 6, right, and so on. So all these set points, humidity, because that's what's important, right? And we can set it up. Now, if you wanted to be able to change that and say, okay, we don't know which the doctor is right now, but we know we're going to be going in for heart surgery.
Got it.
Right? So we can apply that. It's all set up. And that can be done at a nurse's station. Okay, probably not the best one to pick. Orthopedic surgery, polysurgery, right? So we can go ahead and change those parameters, to match whatever the requirement is for that particular surgery, for what that hospital has designed.
Gotcha.
Right? So.
Gotcha. Now, let's talk about the valves, because that's what you guys do. You build these valves. Well, you do other things too, but the speed of the valve, again, it all comes back to that. Why is that important? You mentioned yesterday how many times the door is opened in a surgery room throughout an operation? CDC basically says that on average, operating doors open 6 times every 10 minutes. That's a lot. What?
Yeah, that's crazy, right?
Wow.
So again, I think a lot of that has to do with education, right? Really trying to understand how does pressurization really help me from a sterility standpoint in this space. But that also helps the hospital. If they see that visually, how many times that door is opening, they can kind of say, okay, do I have a workflow issue? Do I have is my anesthesia, nurse going from this operating room to that operating room too much? My booking.
Sure, right.
That, that's the kind of stuff that gives them the power, right,
Mm-hmm.
to try to manage that infection risk better. So,
and that needs to be taken care of. Like, they don't need to be worried about that. They need to be able to go and move when they need to move.
So when it comes to pressure control, again, we have options where we have this, what we call progressive offset control, right? Just like we do in a biosafety lab type of network. If that door opens, we can bring in an inrush in air and still maintain the pressure control, right? While that door is opening. For a basic standard OR, again, tracking pair, maintaining the positive pressure in this space, that's what's important. And when you talk about stability, right, that's the main factor for these spaces. Because hospitals are seeing fluctuations in pressure all the time, right? It can change with people coming in and out of the space. It can change with temperature, humidity, type settings. But when those fluctuations happen, that's what causes the positive, negative sweeps. Right. And with the Venturi valve and the mechanical pressure independence, we don't get that because we have that spring, right, inside that cone and funnel assembly, and it compensates for all those pressure fluctuations. Now, if you had a measuring device in here and it's measuring pressure, and again, if you get those pressure fluctuations, what's that damper going to do, right? So if it's measuring pressure and that pressure is changing, that damper is going to change, go up and down, try to find its point all the time.
It's going to hunt a little bit or overshoot. Is that what we call it?
Undershoot, right? Gotcha. And so that's unstable pressure. And what does that do? That impacts the sterility of the space, right? You're not getting that pure flow from supply to exhaust and getting those CFUs out. You're getting you're pushing and pulling, right? So you're not getting a full efficient removal of those particulates out of the space when you have those fluctuations. And it was very apparent, right? When you remember COVID, all those rooms that these hospitals were trying to take negative, if soon as you say, I'm going to take that patient room and I'm going to turn it into an isolation room for pandemic, situation, I have to put a monitor on that.
It's not as easy as it sounds.
No. And then you see that monitor and you see that monitor going positive, negative, positive, negative. You can't guarantee that you're going to contain that in that space. And what have you done? You just risked all the medically challenged patients that are already in the space. So that's why you started to see other buildings being opened up, stadiums, hotels, to put COVID patients because they couldn't really guarantee that in the hospital.
Yeah. So you got to leave it to the experts is what I'm hearing. Like, I've been here for a couple days now, and this is new to me, these products, but as soon as I sat down and got the presentation of the importance of this, I was like, wow, okay, I get it. Like, I get this is serious business. You got to have the fast acting actuator, the controls, and the experience behind all that too. Like, you guys been doing this for a while, right?
We have. And I think, and that I think is the biggest challenge for people to say, okay, I just want to turn this space negative.
Yeah.
Well, how does that impact the other spaces, right? That air's got to come from somewhere.
Right.
So that's why having tracking pair, volumetric offset type of system really allows you to do that quickly and easily, because if that room down the hall is calling for more air, makeup air needs to be able to compensate for that so that this space, the OR space during surgery, does not go negative.
Yeah. And what we'll do is we'll cut in yesterday's demo we did, showing you all what happens when the building pressure changes and how quickly it reacts, because that was real impressive. So, and I think one of the challenges, if you're a consultant or a contractor or an owner, it's really hard to understand this stuff unless you come here. Like, for me personally, like, until I saw the construction of the facility, of the actual valve itself, the controls, the caretaking, the experience behind it, like, I would encourage anyone who does involved in critical environments in any respect, contractor, account executive, engineer, owner, I don't know if I'm forgetting anybody, but to come here and take advantage of this great facility. We don't charge people to come here, I'm assuming. They can come here for free. No. They can check it out. You can probably curate the visit depending on, I'm an owner and I'm having this problem. What's your solution, right?
Yep.
Awesome.
And that's a key point. I mean, we're here in Acton. We're just 30 miles outside of Boston. It's it's a great facility, and we can show a lot of solutions to help people understand how we can make complexity with pressure control a lot easier for them.
Excellent.
I mean, there's so many things that you can do for these spaces to make them better. And I think that a lot of facilities will just, I'm just going to go constant volume. I'm just going to throw air at it because that's what I can deal with, right? But we do have these systems and solutions that allow them to do both, save energy and maintain safety for the patients and the staff.
Excellent.
You can have both.
Excellent. Thank you very much.
All right. Thanks, Tony.
Thank you for coming. Thank you for having me. Thank you for showing us this. Thank you, Jim. And again, if you want to come check this out, just get with your Phoenix Controls rep or executive and come on down, right?
Yeah, we're open.
All right.